Hey everybody, I just wanted to give you one more example all the way through that you could have where you could do it on your own, but you could also see some things that you'd be expected to do. So I'm going to send you the file that you're seeing on the left-hand side with this video, and I'm going to complete everything in StatCrunch. Obviously, you should be able to, or at least you should practice doing it in your calculator as well to make sure you can type the data in and get everything correctly. I'm going to use StatCrunch just for the ease of the video. So over here, fast food is often considered unhealthy because of its high fat and calories. Here are the fat and calories for several brands of burgers. We'll make the fat the explanatory variable and the calories the response. Again, that's important to make sure you note. Because that's the case, or at least that's the way that we're treating it, we're going to be using fat to predict the calories in the burger. This also means that your fat should go in your L1 and the calories should go in L2. Obviously in StatCrunch that works a little differently, but I have that data over here. So the first thing we should always do is look at a scatter plot. So on your calculator, I don't really care that you can do that. Again, I would provide you with that information. I would provide you with that graph on your exam. But here's our scatter plot. What we're looking for is, does there appear to be a relationship? If there does it appear to be linear? There does appear to be a relationship. It does appear to be linear. Seems like there's this upward trend. The dots are not bending, so we're good to go with the next part of the analysis. Over here on the questions, would you consider this positive or negative, strong or weak, roughly linear or nonlinear? I think I've already answered the fact that it's linear. If you haven't thought about if it's positive or negative or strong or weak, pause the video for just a second and see if you can answer that. So hopefully you did that. This would for sure be positive. We see the dots going in an upward trend, meaning that as fat goes up, calories go up. We also would expect this to be a fairly strong relationship. I talked about putting the dots in a tunnel. So again, we see the trend line that's roughly here, but then think about the tunnel that the dots would have to fit in around this trend line, and that would be a fairly narrow tunnel. So we would consider that a strong relationship. From there, we're going to go ahead and do the analysis, which is going to be the equation, and we're going to interpret all of the things that are there. So here we go. Again, on your calculator, that's stat calc linear regression for us here on StatCrunch. Regression, simple linear. Again, make sure you get your x and your y variables straight. From here, we're just going to hit compute. Bring this over. So obviously, StatCrunch gives you a lot more. I'm just going to look at the part that you're going to get basically on your calculator. So the first thing we should be able to do is to get the equation. So it says write the equation with words as the variable names. So for this one, it would be calories equal to, and again, I don't care if you write the y-intercept first or you write the slope first. Most of you are comfortable, or at least used to, putting the slope first. So that's totally fine. So I'm going to rearrange that in that order. I don't really care where you round it. I went to 2 decimal places. So there's my regression equation. The only thing I can't do here in Word is put the little hat over calories. We should put the hat there. No big deal. So let's get into the interpretations. The first one for the y-intercept. Keep in mind with y-intercepts, the x value is always 0. So that basically means that the fat content is going to be 0. So I would say for a burger with no fat, right, which is no fat content, however you want to say that, we expect the burger to have 210.95 calories. Okay, so there's that one. And again, guys, I encourage you to practice these before you listen to me. I guess I should have said that before I wrote the y-intercept, but I encourage you to practice these, attempt these without watching the video, and then go in and watch how I'm doing them. For the slope, it's always for one more additional thing of the x. I need to go back and get my units. Fat is in grams. So for every additional gram of fat in the burger, we expect calories to increase by 11.06. There's several ways to write that sentence grammatically. As long as it says that one more of fat, 1 more gram of fat, we expect the calories to go up, increase by 11.06. Make sure you have the units, right? Grammatically, my units are here. So if you want to say we expect an increase of 11.06 calories, that would be fine as well. The correlation coefficient is the R. So R, and we generally write it lowercase. So R equals 0.96. That backs up what we had in our scatter plot. If we look at it, right, notice that the dots are following a very close pattern, so we would expect a high correlation coefficient. Next thing here, what is the coefficient of determination? First, you need to know that that's R squared. Sorry, I should write that better. So R and then squared. Again, we generally write that lowercase because we're doing simple linear regression. Capitalized R is generally used for multiple regression, but in any case. So the coefficient of determination is the 0.923, however you want to write that. It is important that you go at least 3 decimals out on that because you're going to, in your interpretation, you're generally going to turn it to a percentage. So for the interpretation, I would say 92.3%. And in general, this is going to be the R squared as a percent. So 92.3% of the variation in the Y variable. So of the variation in, not the Y variable, but in calories, right, which is our Y variable, is explained by the X, is explained by the variation in the X, or in our case, fat content. So that's your interpretation of R squared. Last one, we're just making sure we can do the interpretations here. How many calories would we expect a burger that has 28 grams of fat to have? So I'm just going to go back to my equation at the top. 11.06 times 28, which is my fat content, plus 210.95. Just to do some quick calculations. Again, get your calculator to do that. Let's see, 11.06 times 28 plus 210.95. I got 520.63. And again, that's in calories, right? Calories. Okay, guys, again, I hope that helps with just kind of the general overview of the process that we'll be doing. Again, practice those interpretations. Those are not easy, especially with the grammar sometimes, so practice getting the context in the right grammatical sentence. If you have any questions or anything, by all means, let me know. And again, I hope this helped.